Hello and welcome to my Intro to Linux video. Now this class is for our Intro to Security class that we offer, which is pay as you go. If you don't have much money, you're working 9 to 5 washing dishes, as I have done, go ahead and check down below. You're gonna see a link for a class that's pay what you can. So please check that out. This particular video is brought to you by Wild West Hackin' Fest, which is a conference, and it's also a collection of awesome trainings by Black Hills Information Security and friends of Black Hills Information Security. So check out the conference and check out the training. It is also brought to you by Black Hills Information Security. We offer red teaming services, blue teaming services, network threat hunting. Be sure to check us out. And then also it is brought to you by Backdoors and Breaches, which is our very inexpensive card game getting you familiar with all the phases of an attack and what you can do to counter those attacks. Check it out on Amazon. Finally, it is brought to you by AI Hunter, which is our network threat hunting product, which I personally think is the best network threat hunting product in the world, but don't trust me because I'm a biased person on a video telling you to buy something. So let's jump right in. So whenever you're dealing with Linux, one of the first commands you have to get used to is su space minus and sudo. So let's actually jump straight into, oh my gosh, it's a Windows computer system. This doesn't make any sense. Why are we on a Windows computer system talking about Linux? Well, to be honest, the reason why we're talking about Linux from a Windows computer system is because Windows has something called Windows Subsystem for Linux. Now, the Windows Subsystem for Linux is actually really super cool because it allows you to run full Ubuntu or Kali from your Windows 10 computer. And in our Intro to Security class, this is what I use for my students. So let's actually jump in and let's get started with that. So what I'm gonna do is I'm gonna right click my Windows terminal. I'm gonna select Run as Administrator, okay? Now within my Windows terminal, I have this really super cool feature where I can do the drop down arrow and I can choose Ubuntu 1804. That's my Linux command prompt. So it's built right into Windows. You have to add it. Windows Subsystem for Linux 2 is the one that you want to use. That's incredibly useful. So now you have 2 operating systems in one, which is great. Now, if you look right here, you can see that I have a $sign as my command prompt. Now that $sign is important because what that $sign means is I am not root. What is root? Root is the equivalent of God on a Linux computer system or administrator. You can do almost anything with a root command prompt on a Windows computer system. And in this situation, I'm not root. Now I can do su space minus. That means switch users. And with the minus, it means it's going to bring the environmental variables with me. Now, whenever I do su without identifying a user, it assumes that I want to be root. Now it's going to ask me for my password. My password is ADHD for this VM. Now, you're telling me I mistyped, oh God, I mistyped ADHD? Are you kidding me? All right, let's try this again. ADHD, hit enter. My caps on? Okay, oh, I know what's going on. I'm an idiot, right? Okay, so what are we doing here? Well, whenever you do su space minus, you have to enter root's password. Now, with su space minus, I don't know root's password on this system. I never actually set root's password, but I do know my password for the ADHD account. So now I can try sudo space su space minus. What is going on here? Let's try it. sudo su space minus. Now it's saying switch users and do something and switch users to root. That seems like this is like, capitalism with extra steps involved. But it fundamentally breaks down what password I need to get to root. See, if I run su space minus by itself, I have to know root's password. However, in Linux, you have this wheel group, and it's people that can run commands as root. And my ADHD account is one of those accounts. So if I do sudo su, I enter the ADHD password to become root. So watch. So now I hit enter and it says set the password for ADHD, which is ADHD. Now I hit enter, bam, I'm now root. How do I know I'm root? I have the pound prompt instead. So if you're ever on a Linux system, if you're in my class and you try to type su space minus and you don't know the root password, you're not going to be able to get to root. But if you know the ADHD password, which is in the wheel group, who can run commands as root, you can run sudo space su space minus, which means then you enter the ADHD password. Now, the reason why you do it this way is generally you're not supposed to be running around as root all the time. You're supposed to invoke root commands and do it one at a time and know what you're doing. No one really runs that way, like ever. So most people will do sudo space su space minus become root, do all kinds of things, which a bunch of Linux aficionados will be like, that's not the way you're supposed to do things, but nonetheless. So that is the difference between su and the sudo su command that you have on your computer system. So what's the next command we want to look at? Navigation. How do we actually get around on a Linux computer system? So let's dive right in. So if we look at navigation, first I got to find out where I am. So if I want to know where I am, I type pwd and it says print working directory. This means I am in the /root directory. What does that mean? Well, if I do cd space ... that means I want you to back up now. You're going to back up one directory. So you're going to go or up one directory, however you want to think about it in your head. If I back up one directory and I type ls, you can see there's all kinds of directories. There's bin for binaries, boot directory, dev for the various devices, etc., 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 for various configuration files, and you can see the root directory. So I backed up, and now I can see all the directories that exist on the system. So I can go cd into home and ADHD, and I can type ls, what files exist in this directory? I don't have any files in this directory. Or do I? So if I type ls, it lists the directory contents. I can do ls-lrt to give me a long listing and all the different directories and permissions, but I still don't have anything. But watch, I can do ls-a, and it now shows hidden files. Now, with hidden files, they're not hidden like maliciously hidden. A lot of them are actually configuration files that exist on your computer system. So my bash configuration for my prompt, my bash history, all of these different files are not files that I want to see and work with every day. They're kind of hidden, they're configuration files, but they're basically hidden by putting a dot in the front of the files. So there's kind of how you can move around by doing the cd command and seeing where you're at by doing print working directory, pwd, and seeing what's in that directory with the ls command. So some really, really super cool things that you can do with standard navigation. Now, a little bit more on the file system. Not getting into too much data about the file system, but with the Linux file system, you have libraries. That's like dynamic link libraries on a Windows system, but these would be shared object libraries. We have the proc directory, which is processes that are executing, the root directory, which is root's home. But if you go to the top level directory, you can see all of these different directories that exist. One of the first things that I recommend you do is actually spend some time researching what these directories are. The best way to do this if you're using Windows at home is just install Windows Subsystem Linux and just start exploring and looking at what's there. We have this joke in computer security where people say, well, I don't want to learn Linux because Linux is hard. I want to learn Windows because Windows is easier. And usually the reason why people feel that way is because Windows has a GUI. That's it. But if you talk to anybody in security, Linux or Windows, and they say, if you say Linux is hard and Windows is easy, that proves two things. It proves you don't know very much about Linux, and it proves you know even less about Windows. Windows is not easy. It just isn't. It gives you the appearance of being easy because it has a GUI, but trust me, even Windows administrators will say it is an incredibly complex beast. So install Windows Subsystem for Linux too. Google it, install it on your Windows computer system, and have a great time navigating around the different directories. Now let's say I want to find a file, all right? I want to find a file. There's a couple of different ways that I can do this, right? I can run the locate command, right? I can do locate John. And now it's going to find every single file with the word John in it. Now, on your Linux computer system, it actually goes through and it indexes the entire file system. And with the find command or the locate command more accurately, you can actually go through and you can search for those various files and it'll bring them all back. But this is actually just looking for all files with a name of John. Now, if you ever think that you're sure you have a file, but it's not showing up, you can do update db, and this will go through and re-index the entire file system for you. So if you just loaded a bunch of files on your computer system and you want to make sure that you can still find those, if you load files new and it hasn't re-indexed, it's not going to find them. With update-db, it's actually going to go through and find those files. So that is the update-db command, and then I can rerun locate and find the various files on the system. All right, next up is ls. Now, the ls command allows us to actually list out different files. So let me open up my command prompt again, because I want that. We've already played around a little bit with ls and ls-lrt. I just wanted to spend some more time talking about it. We had talked about how we can identify hidden files. In this situation, if you look really, really closely, there's actually something very, very cool going on here. If you look, these files in Windows Subsystem for Linux, these are all Windows files. And the reason why is the Windows Subsystem for Linux can actually access the C drive of your Windows computer system. So if you want to use Linux type utilities and Linux type of commands, you can actually run those different commands on your Windows computer files. So that's really, really cool that it automatically mounts that share. It also creates a couple of security issues. You can actually put malware on top of Windows Subsystem for Linux, access the Windows system, and a lot of AV products won't actually detect it because it's running inside of Windows Subsystem for Linux, which is kind of a bit of a bummer, but it's just something to keep in mind whenever you're actually looking at it. All right, next one, path. So if you look at your path, I can do echo, and we can do $path. Now, if you notice that $path, that means it's a variable, right? That's an environmental variable. That means that's like a bucket that holds something. And in this particular something, it's going to hold all the directories that my command prompt or my shell, or actually more accurately my terminal, will actually go through and search for to execute files. So if I do echo path, these are all of the different directories that my computer system, my Windows Subsystem for Linux computer system, will search to execute a command. So if I type ls, it's going to execute the ls command. And if I look, the ls command, the directory it executes from is in here. But where? So to find out where, you do which, and you do ls, and it says it's going to execute from the bin directory for the binary files on this computer system. So that's a really cool and easy way that you can identify what programs are going to execute and where those programs are actually going to execute from as well. Now, let's talk about the ever so powerful // This is another area that really trips up people. You have a couple of areas that trip people up all the time. One is becoming root, that trips them up. The other thing that happens is I'm in a directory with a program and I want to execute that program. How do I execute that program? Well, you have to be explicit on Linux and Unix, and you have to actually do the // to actually have it execute. Let's see if I have any files or directories like this. So let's go cd, and I'll type ls, let's become root, dhd, and then I do ls, let's go into opt, ls. So I have a number of different directories that exist here. I'm going to go into the John the Ripper directory. So now if I'm in John the Ripper, I'm going to go into run, type ls. All right. So the John executable is in this particular directory. So you can see that John is in here. This is all part of the John the Ripper program for password cracking. Now, if I try to run John, if I do which John, let me walk through this. If I go John, it's going to say, okay, oh, it looks like it executes. But there's a problem here, right? John the Ripper is installed in the operating system, but in this situation, it's not with a jumbo patch. And in the intro class, we talk about what the jumbo patch is. So if I want to execute John the Ripper, I can do which John, and you can see it's going to try to execute the one in user sbin John. That's not the one that I want. I want to run the one that's in the opt John the Ripper run directory, because they're two completely different versions of John the Ripper. I want to run one that'll crack NetNTLM v2, it'll crack Landman, it'll crack MD5, it'll crack all kinds of different password hashes, and that one's in this directory. So if I just run John by itself, it's going to execute from the user sbin directory. I don't want to do that one. I want to execute the one from here. So if I do John by itself, you can see that we have version 1.8, and this is not the one that I want to execute. But now, if I do ./John, you can see that I have a bunch more options because of the jumbo patch associated with it. And you can see that now it's executing a different version of John the Ripper. In this situation, it's running 1.9.0. Now the ./ means run the file that's right here in this directory. If you don't have one in your path and you're still in that directory and you want to execute a program that's not in your search path, you have to do ./ to execute that particular command in that directory. Another command that I absolutely love is lsof. If you are ever stranded on a deserted island and you're stuck with one command to find out if you're hacked, you want to run the lsof command. What does it mean? Well, lsof stands for list open files. Now, this is critical because everything on your Linux computer system is a file. Network sockets are a file, your video card is a file, your keyboard is a file, your mouse is a file, everything is a file. And if I have the ability to list the open files on a computer system, this is a very powerful command indeed. So if I do lsof like that, it shows me all of the open files on my computer. And that's a lot. So all you need to do in security is just memorize what all those files are. No. Let's actually make this a little bit better. So what I can do is I can run lsof and I can actually restrict it down and show me any of the open iNet connections. So let's create some open internet connections, shall we? So I'm going to open up another command prompt, and I'm going to open up another command prompt and another one. We the best command prompts. All right, so now we're going to do netcat listen on port 2222. Then I'm going to go into the second command prompt, and I'm going to go netcat 127.0.0.1 2222. I'm going to hit enter, and I'm going to type something. This right here is hacking, folks. And I hit enter. And you're going to see that that pops through on the other side. So I created a very simple TCP/IP socket listener where I'm shoveling data back and forth between these two terminals on port 2222 on my Linux computer system. Once again, as I mentioned in a previous video for Windows command line, ports are like rooms. They're like doorways in and out of your computer system. There's 65,536 ports. Somebody called out and they said there's actually only 65,535. They're wrong because 0 qualifies as a port, but we don't need to get into that now. But I have a network connection that's open. Now, if I go back to my prompt with lsof and I rerun it, now you can see that I have a netcat connection open. It says this is the port that's open in 2222, and this is the port it's coming from, which is 47,972. This is very, very powerful for us to be able to identify what types of connections are actually being made on the computer system. And I can even dig in deeper. I can do lsof space minus lowercase p, and then I can put in the process ID of 423. And it says these are all the libraries associated with that specific executable. So we can see what libraries are open, what teletype terminals are associated with it, what it considers to be the current working directory and the root directory. It's an awesome command that we could spend an entire hour working on going through it, but you should be familiar with it. So that's lsof. Next one is ps. So with the ps command, it allows me to see the processes that are running on my computer system. So let me actually just show you that real quick. Let's go back to one of my prompts. Here we go, ps, and it says these are the processes that are running. All right, that's, I guess, okay. You can see there we got sudo, we got su, we got bash, and ps. Well, that's boring. Notice it doesn't have my netcat connections. That's missing things. All right, so what I can do is I can do ps, and now I can do AUX. Now what that means, I want to see all processes sorted by user, including the ones associated with the teletype terminal. Those switches at the end of the PS command are changing the way that PS command actually executes. And now you can see I have a lot more processes that it displays. We can see our init process, we can see our bash processes, we can see our su processes, and we can see our netcat processes. In fact, you can run lsof to find network connections. You can run ps to get additional process information. You can even run netstat and see the network connections from this computer system as well. So there's a lot that you can pull with that. So we already ran through netstat. Let's talk about grep. So with grep, it allows me to search for a string in a file, which I think is pretty cool. So I'm going to cd to my home directory and go Control L to clear my screen. And I'm going to let's go vi file. If I could type file, that'd be great. And in here, I'm going to put in cat, dog, fish, and let's go bird. There we go. All right. So now I've gone through and I've created a file that has a bunch of like words in it, right? So I'm going to close that out. And then I can say I want to search what's in that file. So I can do grep, let's say hi from file. And it didn't pull back anything. All right. So it didn't find hi in the file because hi is not in that file. I can grep, let me zoom in. I can grep dog from file, and it found dog. I can grep cat from file, and it found cat. So it's looking for that specific string. Now, what I can also do is I can do grep cat star, and it's going to search for all the files in this directory that have whether or not cat is in that. So that's pretty neat whenever you're searching for files and validating whether or not files exist. The other command that's incredibly important is the man command. So let's go ahead and let's do this. Let's do man. And man is a manual page. The cool thing about Linux is the user manuals are built into the dang thing. So if I want to learn how a command works, let's say grep, we just got done with grep, I can do man grep, and it's going to open up the user page for grep. So it's going to say, okay, well, we've got name is grep, egrep, fgrep, rgrep, and then we can say synopsis, grep, the options, the description, the various command switches that we can utilize within grep itself, and it breaks down everything that you can do, and probably way, way more than you ever thought you could do with a grep command. This is why you talk to like Linux gurus like Bill Stearns, or you talk to people like Hal Pomerantz. They have this crap memorized because they've been around long enough that when certain switches came out, they were like, yay, my life is now complete. I've been waiting for that, for case and sensitivity for years. So this makes it a lot easier. Now, when you go on forums and you start talking to people about Linux, many times people will tell you, well, RTFM, that's their polite way of telling you to read the fine manual, is what that actually means. Yes, that's what it means as well. All right, so what else do we have? We have the man pages. Now, I talked about this on the Windows section. It is absolutely important that you remember to ping port parse. If you're ever trying to troubleshoot anything on a Linux computer system, and that's not just Linux, but that's for Windows, that's for anything, the three things that you keep in mind to be an InfoSec or an IT rock star, this is all you have to remember, folks, is ping, port, parse. So if I'm pinging, what I'm actually doing is I'm going to ping, let's say 8.8.8.8. Now, when I do this, it's checking to make sure that that remote system is alive. And in this situation, I'm pinging Google's DNS service, right? So we're just seeing if that service is running. Once again, we're not hacking here, okay? We're not trying to hack any computer systems. We're just saying, is that system alive? So we're pinging that system and we're getting responses back from that computer system. The second step I said was port. If I'm having trouble making connections to a remote computer system, I can use Nmap. And in this situation, I'm just going to check port 53 against 8.8.8.8. And it's going to tell me if that port is open. It says it's not open. It's filtered. So let's think about this. Think about it. All right, so I know that that's Google's DNS server. What actually should I be checking on? Well, I checked TCP 53. If I want to actually check and see a UDP port, I can do UDP, and it can come back and it says that port is open. So I'm troubleshooting here, right? We're seeing if that port is actually open on that computer system. So ping and port, can I connect to it with a network connection with ping? And then is the port that I'm trying to talk to for the service I'm trying to get working accessible to me? And then parse. And in this situation, I got a filtered on the first little error, which means that means there's no response. Here, let me show you what that looks like. So if I do, let's do --reason. If I do --reason, now it's saying it's open. That's weird. It was closed. It was filtered. It should come back if it was filtered and say no response, but now that's weird. I got inconsistent results. Oh. But Reason will actually give me a situation as far as why it thinks it was open. So in this situation, it said domain service is open on this computer system, and the reason why is it received a SYNACK. And for understanding SYNACKs, we're gonna have a separate video a little bit later where we're gonna talk about the three-way handshake, we're gonna talk about ports, and a lot more detail. So thank you so much for checking out this video. I hope you check out the other videos that we have at Black Hills Information Security. And I'll be releasing more videos that are introductory videos, especially for our new classes for people that are just getting started in computer security. Once again, if you look down in the notes, you'll see that we have a link to the Intro to Security class, and it's pay what you can. I know that there's a lot of you that want to get into computer security, but your job may not fund it. You may not have a job in security at all, but it sounds really cool and you want to get involved. I want you to get involved. And that's why we're trying to make our Intro to Security class as barrier-free as possible for anybody getting into the field. So thank you so much, and I can't wait to see you in another video. This episode was brought to you by Black Hills Information Security, specializing in pen testing, red teaming, threat hunting, webcast, open source tools, and blogs. It was also brought to you by AI Hunter from Active Countermeasures. The AI stands for Actual Intelligence. Need a threat hunting solution for the network? Check out AI Hunter. It is also brought to you by Wild West Hackin' Fest, currently offering conferences in San Diego and Deadwood, South Dakota. To check out the schedule and the speaker lineup, check out wildwesthackinfest.com.